This lesson is on conversions. And a conversion is going to be a ratio of equivalent measurements. And the ratio should end up equaling 1. So 1 meter is going to have 100 centimeters in it. So 1 meter is equal to 1 meter. 100 centimeters equals 1 meter. Each conversion factor is going to equal 1. Conversion factors are going to be used to convert from one unit to another. And there's not going to be a change in the value, only in the unit. So think of it as having 4 quarters equals $1. A paper $1 bill equals $1. So you didn't change the value of the money, you just changed what pieces of money added up to that dollar. The unit that you're solving for, the one that you want, what you were looking for, is going to go in the numerator. So it's going to go on top of the conversion factor. The one that you already have, the unit that you're starting with, whatever you were given in the problem, that unit is going to go in the denominator. This is so that they can cancel out diagonally, so that at the end you're left with the unit that you were looking for. So the unit that you want over the unit that you have. Want over have. Once you have the unit that you want over the unit that you have, figure out which unit is larger and give it the smaller number, which is typically going to be a 1. The smaller unit is going to get the larger number, so whatever the prefix means. So if you have 1 meter over 100 centimeters, so if we wanted a meter here is going to be the larger unit, so we're going to give it the 1. Centimeter is the smaller unit. A centimeter is smaller than a meter. Centi means 100, like a century, so we're going to give it 100. So 1 meter equals 100 centimeters. You have got to know what your prefixes are and what they represent. So milli, centi, deci, kilo, those are the ones that we use most often. So if we have 36 centimeters and we're going to turn it into meters, first thing you need to do is write down what you have been given. So we have 36 centimeters. Now we're going to set up our conversion factor. So we're going to multiply by our conversion factor. So times. Now, what unit do we want? We want meters. So we're going to put meters in the numerator. What unit did we already have? What are we starting with? We're starting with centimeters. So we're going to put that down here in the denominator. Now, which unit is larger, a meter or a centimeter? Meter is the larger unit, so we're going to assign it the 1. Centi means 100, so we're going to put 100 on the bottom. And then you would do the math. So you're multiplying by a fraction. So 36 times 1 is just 36. So all you have to do here is divide 36 by 100, which is going to be the equivalent of moving your understood decimal here 2 places to the left so that you get 0.36 meters. Notice that your centimeters canceled out here. You were left with meters, which is what you were looking for. So convert 0.746 centimeters to kilometers. Now here we're going from a prefixed unit to a prefixed unit. And some of you may know how many centimeters are in a kilometer. Some of you don't, and that's okay. Honestly, everyone should be following this step in order to prevent error. If you're going from a prefixed unit to a prefixed unit, you need to go to the base unit first. And the base unit is going to be the one that both of these guys have in common, which in this case is a meter. So you're going to go from centimeter to meter to kilometer. So when you have a prefixed unit, you're going to have a 2-step conversion factor. So we're going to start with our 0.746 centimeters. And we do want kilometers, but we need to go to meters first. So we're going to multiply by our conversion factor. We want meters next, so we're going to put it in the numerator. And since we have centimeters here, we're going to put that down in the denominator. Decide which one's larger. Meter is larger, so it will get the 1. Centimeter is smaller, so it's going to get the prefix meaning, which is 100. Our centimeters units cancel out, and we have meters. But meters isn't what we want for our final answer. So we're going to go one more step. We're going to put the unit that we want, which is now kilometers, in the numerator. And what we have, meters, that's what we're left with at this point. It's going to go in the denominator. Now, which unit is larger, a kilometer or a meter? Kilometer is going to be larger, so it's going to get the 1. Now, meters doesn't have a prefix. It's a base unit. But you're going to use what kilo means, which is 1,000 times larger. So it's going to take 1,000 meters to make a kilometer. So now our meter units cancel. We're left with kilometers, which is what we were ultimately looking for here. So now we can do our math. If you have a 1, remember you can ignore it because 0.746 times 1 is the same as 0.746. If you have a value, you're going in the denominator, you're going to divide by that value. So we have 0.746. And when you divide, you're going to move the decimal to the left. So we're going to move the decimal to the left 2 places for 100. 1, 2. Then we have to divide by 1,000. So now we're going to move it 3 more places to the left. 1, 2, 3. Which gives us a final answer of 0. 1, 2, 3, 4, 5 zeros, 7, 4, 6 kilometers. Now, you can leave your answer like this. That is fine. It is perfectly acceptable. It is the correct answer. But the other day, we learned a better way to write numbers that have a lot of zeros for placeholders. Scientific notation. So you can take this decimal and you're going to move it back. Remember, with scientific notation, our starting number has to be greater than or equal to 1, but less than 10. So we'd have to put our decimal here in order for this number to be greater than or equal to 1, but less than 10. So our starting part of our number is going to be 7.46. Then the scientific notation part is times 10. Now we have to figure out our exponent. Since this value is less than 1, we're going to have a negative exponent. And we're going to count how many places we moved our decimal. 1, 2, 3, 4, 5, 6. So that's going to be our exponent. And don't forget your unit of kilometers. And this would be your final answer. Okay, you also have to know how to do temperature conversions. The thermometers that we use in class are Celsius. Everything we measure will be in Celsius. But there are going to be some formulas that you're going to do later on in class that require you to have the temperature in Kelvin. You're also going to have a worksheet that's probably going to ask you to convert to and from Fahrenheit. So if you have Celsius and you want Fahrenheit, you're going to use this formula. So you're going to do 9 divided by 5 times the degree Celsius plus 32. So that plus 32 is on the end. So these guys should be in their own set of parentheses. So 9/5 times your Celsius temperature, then add 32. That's going to give you your Fahrenheit temperature. And to get Celsius from Fahrenheit, you're going to do 5/9 times your Fahrenheit minus 32. So these guys are already in their own separate parentheses, so you're just going to follow that as it's written. And you do not need to memorize the Fahrenheit to Celsius, Celsius to Fahrenheit conversions. Those would be given to you if you need them. But you do need the Kelvin to Celsius. You need to memorize these conversions. If you have Kelvin and you want Celsius, you're going to subtract 273. And to get to Kelvin from Celsius, you're going to add 273. So to get Celsius, take your Kelvin temperature and subtract 273. To get a Kelvin temperature, take your Celsius and add 273. So these are the only sets of temperature conversions you need to memorize. Fahrenheit to Celsius and back would be given to you if you needed it.